If you recall, I already created a tutorial on designing nuts and bolts for 3D printing. If you haven't seen it yet, I'll leave you the link in the description down below. But what about creating threads by strict engineering specifications? In this video I'll show you how to create these threads using a simple method based on the ISO 681 standard. Think of this as the theoretical foundation. It's just an equilateral triangle with sides equal to the pitch. I will break down all of this into simple equations so we can apply it as parameters in Shapr3D. So let's get started. Let's start by creating a variable. Let's go to add, variable. We will start with the designation, which is M, the nominal diameter, 4 millimeters. The next variable will be P, which is the pitch, 0.7 millimeters. Okay. Next one will be the thread length, TL, will be 5 millimeters plus the pitch. This is because we will start the thread with an offset which is equal to the pitch. To achieve a functional 6G tolerance fit, I have added a clearance. You can check out in the table, 0.092 millimeters. The next one is the machined diameter, which is equal to the nominal diameter minus the clearance. And finally, the number of revolutions, which is threaded length over the pitch. And we will multiply this by 360 because revolve feature input is in degrees. Now create variable, and perfect. As you can see, we have here all our variables or parameters, as you want to call it. Let's start by creating a sketch. On the top plane, draw a circle, draw it to the center, and this diameter will be dm. Now let's extrude this profile, 5 millimeters. Let's create a sketch on the front plane. Draw a line from the center, make it constructive. Now let's draw a horizontal line, make it constructive too. Great, these lines will be our guides. Let's trace a triangle. This will be the profile of the cut tool. Select all the sides and make it equal. Now this will be P and OK. Let's mate this point with our horizontal guide. Let's zoom in a bit. We will cut the profile with a vertical line. Okay, let's trace another one from this point to this point. Drag it a bit and add a horizontal vertical relation. Perfect. Add a dimension for this line, P minus P over 8. Okay, now it's fully defined. Let's trace a vertical line, and this dimension will be P over 4. Perfect. Our profile is complete. Let's select the inner profile, go to More, Revolve, and select the axis of revolution. Then change this for minus thread length. Perfect. Let's now change the angle parameter. Will be N. Okay, let me check that the direction it's okay. It's inverted, so let's change the sign. Minus N. Done. Great. Now let's add a construction plane. This face. Okay. And let's drag it. This one will be minus TL plus P. This will allow us to cut the helical part to the desired length. Now let's go to Tools, Split Body, select the helical part and the plane, and done. Now go to Items and remove this part. Okay. Let's hide also the construction plane. Okay, go to Tools, Subtract, the inner part, then this one, and done. Let's now hide the sketch. And now let's see the magic of our parameters. Let's change to 6. Perfect. Now to 5. M7. Everything works great. Now let's change the threaded length. Only change the number. In this case will be 3 millimeters. Awesome. Now let's change this to 5 millimeters. You can see the advantage of all these parameters. Let's now create an M6 with a pitch of 1. And the clearance will be 0.116. Great. So as you can see, this is a really easy method to construct standard threads. And we only need to add the head, and that's it. Thanks for watching.